Today we're doing a quick structured look at the history of database management systems, DBMS.
Right.
We want to track how we got from, well, punch cards basically, all the way to the global networks we use every day, just hitting the key turning points.
Okay. And just to start, a DBMS, it's basically software to organize, store, and get data back out again. Simple as that.
Simple concept now, maybe.
Well, yeah. But the origin, it actually goes way back before computers as we know them. Think Herman Hollerith, 1890. He adapted punch cards, the kind used for weaving looms.
Weaving, wow.
Yeah, for looms. He adapted them to be the memory for mechanical tabulators. That was the seed.
Okay, so that idea was there, but then when commercial computers started popping up, say, early 1950s, data wasn't the focus initially, was it?
No, not at all. Early programs were all about the algorithms, the calculations, data, names, lists, addresses. That was sort of seen as the leftovers.
Leftovers.
Yeah. But the second computers went commercial, suddenly organizing those leftovers became, well, critical.
And that need kicked off the first phase, right? The navigational databases.
Exactly. The first real DBMS came around 1960, Charles Bachman's integrated database system. IBM's IMS followed pretty quickly.
Okay, IMS, I've heard of that one.
Right. And these early systems, they were quite complicated. This led to the CODAFL approach, standardized around 71.
Ah, CODASL. Now, wasn't that the system that was notoriously difficult, like a maze?
That's a good way to put it. Finding data meant you had to navigate manually. You either needed the exact primary key, or you had to painstakingly follow these predefined links, record by record, or, worst case, scan the entire database.
Oof, sounds slow. And needed tons of training, I bet.
Absolutely, which is precisely what Edgar Codd, working at IBM, found so inefficient. He wrote this really groundbreaking paper in 1970.
Okay.
He proposed the relational model. Forget linked lists, he said. Store records in simple tables, fixed length records, much cleaner. He really wanted proper transaction safety.
Wait, hang on. He worked for IBM, the IMS people, and he basically said, let's ditch IMS.
Huh. Well, yeah, pretty much. It was radical. And IBM, understandably, was skeptical at first. They'd invested so much in IMS already.
I can imagine. So what happened?
Well, the breakthrough came from outside IBM initially, UC Berkeley. Their Eingeries project in '73 proved Codd's relational model actually worked. It was practical.
Ah, university project proving the concept.
Exactly. And that put pressure on IBM. They then developed SQL, structured query language, in 1974.
SQL, the standard.
Pretty much became the functional standard, yeah. And these systems really focused on AC properties, atomicity, consistency, isolation, durability. That became the gold standard for keeping transactions safe.
Right, acity. And that relational model, that standard, really hit its stride later, didn't it? Like with MySQL.
Absolutely. Phase 3, you could say, MySQL comes out in '95. Open source, super reliable RDBMS. Even today, it's arguably the most popular database globally.
Still dominant. But even with powerful systems like MySQL, the internet threw a wrench in the works, didn't it? All that messy data.
Oh, definitely. Faster processing was great, but suddenly we have this flood of unstructured data. Art, photos, music streams, videos.
Stuff that doesn't fit neatly into rows and columns.
Exactly. Relational databases just weren't built for that kind of non-relational, schemaless data. Data where you don't need a rigid table structure defined up front.
So the pressure built again.
Yeah.
And that led to NoSQL.
Precisely. NoSQL meaning not only SQL, it was the answer to the internet's need for, well, massive speed and scale. Think Google, Twitter.
Handling just colossal amounts of data.
Right. NoSQL systems are often distributed, they scale out much better, and they have that flexible scheming we talked about, vital for handling diverse, unstructured information quickly.
And that flexibility, that need for speed, it led to even more specialization, right? Phase 4.
Yeah, you started seeing specialized non-relational databases pop up. Like document stores, MongoDB is a big example.
How do those work?
They save whole records, essentially, in one semi-structured document.
Yeah.
It makes mapping data to objects and code much easier, so it's really popular for web development.
Okay, makes sense.
And then there are graph data stores, which emerged around 2006. These are fascinating. They store the relationships between data points as actual first-class citizens in the database.
So the connection is the data, almost.
In a way, yes. Perfect for things like social networks, recommendation engines, or even mapping complex routes.
Very cool. And the final piece seems to be intelligent databases. That sounds futuristic.
Well, the concept actually dates back to 1989. The idea is to move beyond just storing data to managing information. using AI data mining techniques.
To make the data actually useful without complex queries.
Exactly. The goal is natural, useful output. Imagine a hospital system that doesn't just give you records, but instantly pulls together a patient's entire relevant history from decades of visits. That's the idea.
Wow. Okay, so we've really gone from mechanical looms storing census data to these incredibly complex, distributed, even intelligent systems.
It's been quite the evolution. And I think the main takeaway for today, the really key concept now, is something called polyglot persistence.
Polyglot persistence, meaning
Meaning there's no single best database anymore. Different technologies are better suited for different kinds of problems.
so modern applications, they probably need to talk to several different types of databases at once.
That's the challenge in the philosophy. You design systems to use multiple specialized DBMSs simultaneously to get the best fit, the best performance for each specific task.
A mix and match approach.
Right.
Wow.
So the thought to leave you with is this. Just think about your own day. How many different kinds of data systems, relational, graph, document, key value, do you think your digital life relies on? Probably without you even realizing it.